Hello everyone, here is the continuation of the work example 2 that I have started. I just solved one question but I didn't answer the second question. So the second question says that a boiler plant working at what? At a pressure of 1.4 mn per watt per meter square evaporate 8 kg of what? Of water per kilogram of coal fired from feed water at 39 degrees Celsius. The steam at the stove bulb is 0.95 dry. So we are to determine the what? The equivalent, which means the EE, the equivalent evaporation. So the first thing that we are going to do is that the formula for the equivalent evaporation, it says it is the same thing as what? As M multiplied by what? Multiplied by Fe. And you have to take note that Fe itself, it is the same thing as H minus the enthalpy of what? Of feed water divided by what? By 2257. So you have to take note of this. Tear a sheet of paper and write the formula down. So the first thing, I have my mass. What will be the mass? The mass, which is 8 kg. So you have to take note of this. And whereby H is what? Is enthalpy of wet steam. And the H of FW. The H, this H, it is indicating what? Enthalpy of wet steam. And this H of FW, it is the enthalpy of feed water. And this 2257 is what? Is the latent heat at what? At 100 degrees Celsius, which is measured in what? In kilojoule per kg. I have to get it. This 2257, which is 2257, it is what? It is a latent heat at 100 degrees Celsius. And this H of FW, it is something as enthalpy of feed water. And the H, it is what? It is the enthalpy of wet steam. So I have to get this. So the next thing that we are going to do here is that from the steam at 14 bar, because this 1.4 mn per meter square, if I am to convert it to bar, it will now become 14 what? 14 bar. So from the steam table, what will be our H of F and what will be our H of FG? So let's check the steam table and see. So from the steam table, we are asked at 14 bar. So you have to take a look to 14. So this is saturated water and what? And steam. So you have to take a look to 14. So this is 14. So I'm going to first find the S of what? Okay, sorry, the enthalpy of F, which is the H of F. So this is my 14 bar. And therefore, I will say this is what? This is H of F. As you can see, so I'll come across a H of F. So at the end, I'll say this is 14. I'll come across like this, and this is what? This is H of F. So I'll pick my H of F as what? As 830 kilojoule per watt per kg. And also I will look for H of FG. H of F and G is the same thing as what? It is H of FG to 14 bar. So this is 14 bar, as you can see, 14 bar. So I'll have what? 1960. So 1960 will be my what? My H of FG. So you have to take note of the values. My H of F is 830, and also my H of FG, it is what? It is 100. Okay, sorry, it is 1960. So I'm going to use the values H of F and H of FG to find what? To find my enthalpy, since I have what? I have the dryness as 0.95. So you have to take note of this. So I hope you see it. So our H of F, it is what? It is 800 and what? And 20 what? And 20 kilojoule per watt per kg. And also the H of FG, which is 1960, as I show you. So therefore kilojoule per watt, kilojoule per kg. Since the steam is what? It has 0.97 dry, so which is the dryness fraction. So my H will now be equals to the H of F plus what? Plus X H of what? H of Fg. At the end, my H will now be, what will be the H of F? Which is 830. So I will say 830, and therefore I will say plus what? Plus the dryness fraction, which is 0.95 multiplied by 1960. So let me see what should I going to get. So at the end, the value of the H, let me do like this. I'll say the value of the H will now be equals to 2692 kilojoule per watt per kg as the value of what? As the value of the enthalpy of what? Of wet steam. So the next thing that I'm going to find is what? Is the feed water supply. So now I already find H. Now I'm going to find the H of FW, which is the feed water supply. So let me have some space, but you have to take note of this value. So therefore, the feed water supply at what? At this 39 degrees Celsius. What will I going to say? So what should I going to say? So I'll now say the H of FW will now be equals to the formula, which is Cp multiplied by what? Multiplied by the temperature. So this will now be equals to the Cp. I'm going to use the constant, which is 4.187 multiplied by what? Multiplied by the temperature, which is what? Which is 39. So I'll say multiply by 39. So what should I going to get? So at the end, the H of what? The H of FW, it will now be equals to 163.3 watt, 23 kilojoule per watt, kilojoule per kg. So the next thing is that the factor of the evaporation, which is the Fe, because from the beginning I said something called Fe, which is the same thing as H minus H of F, H minus H of FW divided by 225 what? 57. So this will now be equals to the value of H, which is 26 what? 2692 if you can remember, and therefore minus 163.3, which is the what? Which is the feed water supply, which is this. So therefore I have to divide it by 225.57. So what should I going to get as what? As my factor of evaporation. So the factor of this evaporation, which is the Fe, it will now be equals to what? 1.120. So the next step to do is I'm going to calculate my what? My equivalent evaporation. So from the first formula that I write, I said EE, it is the same thing as what? Sorry, as M multiplied by what? By F of E. So this will now be equals to what will be our M? Our M, which is the mass, it is 8 kg multiplied by Fe, which is 1.120. So this should now be equals to the EE. Our EE, which is the equivalent evaporation, will now be 8.96 what? Kilojoule what? Steam per kg coal. So this is what? This is a final solution to what? To this second question. So this is the end of the second question. If this video is more helpful to you, please consider subscribing so that you will be notified immediately if I uploaded any content. For those that need the solution to this first question, they can check the description of this video, or they can check out the playlist of what? Of thermodynamics 2. Thanks for watching and do have a nice day.